Most onboard chargers will have some kind of liquid-cooled heatsink, and in this one, that's actually the base of this unit. You can't see it, but at the very back here, there are two inlet and outlet ports for the liquid cooling, and that goes through the entire base of the unit down here. The circuit board and the MOSFET are both mechanically attached, but there's still going to be an air gap there that we need to fill in with a thermally conductive material. And you can either, for something that's mechanically attached, what you're going to want is probably a high thermal conductivity, what we call a gap filler. It doesn't have a high adhesive strength, but it has a very high thermal conductivity. And so SC1600 is this material that's shown right here underneath the MOSFET. That's a material that applies thick. It's kind of like toothpaste. So you would apply a couple of beads of that material under here and then press this down and mechanically fixture it. You can see from the squeeze out what the material looks like here. If these parts are not mechanically fixtured, then you can use thermally conductive adhesives to bond them onto there. Instead of using SC1600 gap filler, you could use TC2002 or TC850 thermally conductive acrylic adhesives. Those are strong adhesives, particularly good for bare metals, like you can see here with the cold plate, and they would provide a structural bond to the point where you wouldn't need any kind of mechanical fixturing. The transformers and the inductors are actually very complex shapes, so you've got to get into all the different wires and nooks and crannies there, and so the best way to do that is to use what's called a potting material. Potting materials are self-leveling, so you mix an A and a B side together, it becomes very runny, and then you can pour that into here, and so this pink stuff that's kind of all over the place down here is potting material. Notice that we haven't had to fill the entire unit, because really all you need to do is make thermal contact between the hottest parts of the inductor and the transformer, which is where the connections are made. And once you pull the heat away from there, then that will cool the rest of the unit pretty efficiently. The other thing is, if you're concerned about weight, you don't have to fill in the entire bottom of this. You can actually build what's called a dam, or you can build a little mold that goes around just these units and just fill in that dam or that mold. So you can save some weight that way. Finally, these capacitors up here are potted with a relatively hard, rigid material. It's an epoxy. Not necessarily thermally conductive unless you're seeing a heat problem with them, but it will provide good mechanical rigidity, good protection from the elements for the kinds of capacitors that are in here. And so those are the main materials that we would use in this kind of onboard charger application.